In this first video, we're going to review how to graph linear and quadratic functions and how to transform them left, right, up, down, reflect them, and then we'll move on to different types of functions such as cubics or square roots or others, and we'll get to those in a little bit. So this first one on the left here, 2x plus 3, we can tell it's linear because it's in that y equals mx plus b form, the slope-intercept form. If I'm looking at my function, the 2 is what's going to tell me my slope, and the 3 is going to identify what my y-intercept is. And if I can know what my slope and my y-intercept are, I can graph this line. So I'm going to go ahead and draw my x and y axis. And based off of what I know right now, I can go up 3 and put in a point. Looks something like that. And then from there, the slope of 2 tells me that I need to go up 2 to the right 1. So I'm going to go up 2 more to 5 to the right 1. Then I can put another point right there. And then from that, I can go ahead and draw on my line to connect those 2 points to look something like that. So y-intercept is at 3, we can go up 2 to the right 1, and we can continue to do that to find other points. If it was a negative slope, we could go down 2 to the right 1 instead of up 2 to the right 1, and find the graph that way. On the second one, we can start out with the fact that we know it's a quadratic because of the x being squared here. So I know that this is either going to be an upward-facing parabola if it's a positive x squared, or a downward-facing parabola if it were to be a negative x squared. The other two things we want to look at are this minus 2 and the plus 1. The minus 2 is going to be a horizontal shift, and in this case it's going to go to the right by 2 units. If it were an x plus 2, then it would have gone opposite and gone to the left. With the plus 1, on the outside of the grouping of x squared, this is going to tell us an up or down shift, and since it's positive, we're going to keep that sign and shift it up 1. So with that information, knowing the general shape and then where it's located, I'm going to draw my x and y axis and start out to the right 2, up 1, and from that point, I'm going to put a point in right there. From that point, I can go ahead and draw my parabola. So the left side's going to come up that way, the right side's going to come up that way, with the vertex to the right 2 and up 1. So now looking at both of these, we want to also be able to identify what is the domain, what is the range. So if we look back to the first one that we had, a linear function goes forever left and right. So both of these would have a domain and range of all real numbers, or negative infinity to positive infinity if you chose to do interval notation. If we're looking at this second one, the domain still has an unlimited value. So our domain is still all real numbers, but with how the graph is shaped, we're limited on where we can be for the range. So in this case, I would say our range starts at positive 1 because that's the lowest value on the parabola, and then goes off till infinity. So based off of our parent functions is what we call them, we can transform these graphs up, down, left, or right, and then base our domain and range off of those values.